9.1 covers rational functions. The key vocabulary here is a rational function. Basically what a rational function is when you wind up with x as a denominator in some type of polynomial format, whether it be a monomial, a binomial, a trinomial. When you have a rational function, the big thing here is your qx. Qx cannot equal 0. Okay? You cannot have 0 as a denominator because you cannot divide by 0. The way to find out those values that x cannot be is called your excluded values. Basically what you would have here is you'd set your denominator equal to 0 and you would determine as an equation what x cannot be. Asymptotes are lines that the graph will never cross or never approach. Basically they're pointing out what values of x cannot be. So for instance, in example 1, you see that the denominator here, x, what you're going to do is you're going to find out your excluded values. So you're going to set it equal to 0. So in this case it's pretty simple, x equals 0. This is telling you the excluded value is 0. Okay, you cannot put in 0 for x because you cannot have negative 2 over 0. You cannot divide by 0, and you could check that out with your calculator. In example 2 here, you take the denominator again and set it equal to 0. So you would have 4x minus 8 equals 0. Basically solve for x, so I'd add 8 to both sides. We have 4x equals 8. Divide this side by 4. Divide this side by 4. And this would give us x equals 2. So what this is telling us is that you cannot put in 2 for x. The reason why, 4 times 2 minus 8, right? When we do this, we'd have 8 minus 8. 8 minus 8 would give us 0. We cannot divide by 0 in this problem. So that's basically what the excluded values are pointing out, is what x cannot be, because that would be, the denominator would be 0. So our next step here is we're going to actually go ahead and graph these rational functions. When doing these rational functions, you'll have to identify a vertical asymptote and a horizontal asymptote. Okay? What you'll want to do is graph these right away. Up above, it shows us how to find these vertical and horizontal asymptote. Basically, to find your vertical asymptote right here, it's x minus b. What they're showing there is the denominator. What you're going to use is essentially the excluded value method. So to find your vertical asymptote. So my vertical asymptote, I'm going to take this right here and set it equal to 0. So x plus 2 equals 0. Solve for x, and we have x equals negative 2. So what you're going to do is you're going to graph that vertical asymptote. X equals negative 2. Here's where x equals negative 2. And I just make a little dotted line here. That is my vertical asymptote. Next, I would find my horizontal asymptote. My horizontal asymptote, right here, that is y equals c. There's your c value. So I look over here, this equation does not have a c value. So my horizontal asymptote is going to be y equals 0. There's nothing there for c. So where y equals 0, it crosses my y-axis at 0. So I'm coming across right here. Right across that axis, it crosses the y-axis at 0. And this would be my horizontal asymptote. What it's going to do is you're going to go ahead and this will help you graph that rational function. So when I graph a rational function, I can put any value I want in for x. Here's the rule of thumb. You cannot use my excluded value. My excluded value is negative 2 because my denominator would be 0. Negative 2 plus 2 is 0. So what I do is I'd say I can't use negative 2. Okay, not applicable, NA. So what I do is I use 3 values above the excluded value and 3 values below the excluded value. Alright, so my 3 values above my excluded value would be negative 1, 0, and 1. The 3 values below, negative 3, negative 4, and negative 5. So what we would do with these values is simply input them in to the regular equation over there for x in the denominator. When I put in 1 right here, we have 1 plus 2 would give me 3, so I'd have 2 over 3, which would give me 2/3. I input 0. 0 plus 2 is 2. 2 over 2 would give me 1. I would input -1. When I input -1 and do my operation, I get 2. When I put in -3, -3 plus 2, -3 plus 2 is -1. 2 over -1 is -2. Throw in -4, I get out -1. Throw in -5, I get -2/3. Now I'm going to go ahead and plot these points here. Plot the first set of points here. I'll go with those 3 here. I've plotted the first 3 here. When I plot the first 3, remember your vertical and horizontal asymptote, your graph will never hit that line. So it's going to go on forever and ever, and it's never going to touch that line. And then it'll come through just like this. So you get that nice curved looking graph. The next thing I would go ahead and do is plot my next 3 points right here. And basically what is going to happen is you're going to get another image down in this area, down on this side, and it would basically be a mirror image of the other portion of the graph. So I've plotted those points. Again, my graph here will never intersect those asymptotes. If it does, that tells me I did something incorrect. And there's my other portion of the graph. That's what our rational function graphs look like. So again, to start off my next example, I need to go ahead, start off by finding my horizontal and vertical asymptote. Graph those on my coordinate plane. Vertical asymptote is what that denominator can't be, so I'm going to take this portion, set it equal to 0, and we have x equals 2, so that would be crossing my x-axis at 2. Here would be my vertical asymptote. Next, find my horizontal asymptote. Horizontal asymptote, remember y equals c. I do have a c value here, so I would say that it would be y equals 1. It crosses my y-axis at 1. There's my horizontal asymptote. Next thing, I'd find out my excluded value. Your excluded value is simply what your vertical asymptote is like. I'm going to take that denominator there, x minus 2, right? So set it equal to 0, add 2, and you have x equals 2. So x cannot be 2. Remember, I put that in my graph. I say that is NA, not applicable. And then I go ahead and state 3 values above and 3 values below. There would be my 3 values above and 3 values below. Input those into my equation for x and do my computation. There's what my table would look like with my computation there. Then I'm going to go ahead and graph these top 3 here. Plotting the top, I have -1 and 1.3. So over -1, up 1.3, somewhere in here. 0, 1.5, 0, 1.5, somewhere in there. And 1, 2, plot. And again, you get that curve. That'll never touch your horizontal and vertical asymptote. My orientation's a bit off. Should never touch that horizontal asymptote. Same thing, graph x values 3, 4, and 5. And again, it's going to create that mirror image, so we know that the graph should be down here, somewhere in that section. And your graph should look something similar to that. This will conclude 9-1, lesson 49, rational functions.